Hello everyone, this is P. Jithendar, Assistant Professor in Electrical and Electronics Engineering, MLR IT, Hyderabad. In today's video lecture, I am going to discuss about the Thevenin's theorem. So here the main overview of the main Thevenin's theorem is, statement. So what is the statement of Thevenin's theorem and what is the procedure involved in the Thevenin's theorem? And what is the verification, how we can verify the Thevenin's theorem. Okay, so these are the we need to discuss in today's session. So here the main statement, the first point is we have to discuss about the statement of Thevenin's theorem. So here the statement of Thevenin's theorem is, in any linear or bilateral network, contains one or more voltage sources, the total voltage is replaced by Thevenin's voltage. The total voltage is replaced by Thevenin's voltage and the total resistance is replaced by Thevenin's resistance in series with load resistor RL. That is the statement of Thevenin's theorem. Okay. So here for this I am taking one simple circuit. So here I am taking one simple circuit, so which is having 3 resistors and having the supply, and here we are having the load. So this is load RL, load resistor I am taking as a RL, and the resistors are, this is R1, I am taking this is R2 and this is as R3. Now the supply voltage is plus minus voltage is V. So here I am taking the one simple circuit, so which is having the source voltage is V and the resistors R1, R2, R3 and the load resistor is RL. Now here in this Thevenin's theorem, so we have to find out the current through this load resistor. We need to calculate current through this load resistor, right? So here this main circuit, we need to draw the one Thevenin's equivalent circuit. So that is, so according to statement of Thevenin's theorem, the total voltage, so this total voltage is replaced by Thevenin's voltage, that is VTH. The total voltage is replaced by Thevenin's voltage, that is VTH, so plus minus VTH, and the total resistance, that is R1, R2 and R3. So these total resistors are replaced by Thevenin's resistance, that is RTH, replaced by RTH, that is Thevenin's resistance in series with the load resistor RL, So this is the equivalent circuit of Thevenin's theorem. Now here across the load we need to calculate the current. Okay, so here the statement of Thevenin's theorem is, in any linear or bilateral network contains one or more voltage sources, the total voltage is replaced by Thevenin's voltage and the total resistance is replaced by Thevenin's resistance in series with the load resistor RL, right? Here is the first one, and next one we are having the procedure. So the procedure involved in the Thevenin's theorem. So here the procedure of Thevenin's theorem is, so here we are having the some steps. So step number 1. So step number 1 is, first we have to find out the total number of loops in a given circuit, right? Suppose if the circuit having the 2 loops, so we are having the 2 currents. If we are having the 3 loops, so we are having the 3 currents, right? So here step number 1, so first we have to find out the total number of loops. After that we have to give the current directions, that is the step number 1. So here we have to give the current directions and here we are having the total number of loops. So first we have to find out the total number of loops, so after that we have to give the current directions, that is step number 1. Now the step number 2 is, so here step number 2. So the step number 2 is, so we are having the source voltage. So in that the source voltage, so we need to replace with the Thevenin's voltage, that is VTH, right. So for example, so here I am taking the same circuit here. So here we are having the load. So load is RL and resistor is R1, R2, and this is R3 plus minus V. So here step number 2. So step number 2 is, so we need to find out the Thevenin's voltage. So how we can find out the Thevenin's voltage? So in that case, we need to remove this load resistor. We need to remove the load resistor. Now across these two terminals, we need to calculate the Thevenin's voltage, that is VTH. Okay, we need to remove the load and we need to calculate the Thevenin's voltage across these 2 points. So here we will get the VTH, that is Thevenin's voltage. That is step number 2. And the step number 3. So here the step number 3 is, we need to calculate the RTH. So here is the step number 3. So in this step number 3, we need to calculate Thevenin's resistance, that is RTH. Okay, RTH is nothing but Thevenin's resistance. So how we can calculate the Thevenin's resistance means, here by short circuiting the voltage source, here by short circuiting the voltage source, and we need to remove load. We need to remove the load resistor. Now across these 2 terminals, we need to calculate RTH. Okay, so here the resistors R1 and this is R2 and this is R3, right. So here the step number 3. Step number 3 is, we need to short circuit the voltage source and we need to remove the load resistor. So across the load terminal, we need to find out RTH, that is Thevenin's resistance. After that, so finally, according to statement of Thevenin's theorem, the total voltage is replaced by Thevenin's voltage. So here the total voltage is replaced by Thevenin's voltage, that is VTH, and the total resistance is replaced by RTH, that is RTH, Thevenin's resistance, in series with the load. So this is in series with the load resistor RL. Now at this RL, we need to calculate the load current IL. So here IL is nothing but, so IL is equal to, so the equation is VTH divided by RTH plus RL. So by using this equation, we can find out the current through load resistor, that is the step number 5. Okay, so these are the steps involved in the Thevenin's theorem. Okay, so after that we have to verify. So we have to verify the Thevenin's theorem. So how we can verify the Thevenin's theorem? So by using the Kirchhoff laws or by using the nodal analysis or by using the mesh analysis, we can verify the Thevenin's theorem. Okay, so here I am taking the one example here. So here, so the verification of Thevenin's theorem, in that case I am taking the one example here. So in that case, the question is, calculate current through 10 ohm resistor. So we need to calculate current through this 10 ohm resistor by using Thevenin's theorem. Okay, so in that case, so we are having the step 1. So step number 1 is, first of all we need to find out the total number of loops in a given circuit. Okay, that is step number 1. So here, so we are having the 2 loops here. So this is first loop and here is the second loop. So we are having the 2 loops. So 2 loops means we are having the 2 currents here. So first loop current is clockwise direction and second loop current is anti-clockwise direction. So here I am taking current, first loop current I am taking as I1 and second loop current I am taking as I2. So means current through 4 ohm is I1 and current through 6 ohm is I2, and now current through 10 ohm. So here I1 towards this node point, I2 also towards this node point. So from this node point the current direction is downwards. So here I am taking current as I3. Okay, so these are the current directions. So current through 4 ohm is I1 and current through 6 ohm is I2 and current through 10 ohm is I3. So I3 is nothing but I1 plus I2. Okay. So here is the step 1. So step 1 means we have to find out the total number of loops. After that we have to give the current direction. So that is step 1. So step 1 is, so find total number of loops. After that we have to give the current directions. So we need to give the current directions. That is step 1. Now step number 2 is we have to find out, or we have to finding of VTH. So how we can find out VTH? Okay. So we need to find out the VTH value. So how we can find out VTH? So here 10 ohm is load resistor here. 10 ohm is load resistor. So in that case we need to remove the 10 ohm load resistor. We need to remove the 10 ohm load resistor. Now at the two terminals we need to find out the VTH. Okay. So here I need to redraw the circuit here. So here load is open circuited. So load is open. So plus minus. So this is 20 volt plus minus, and this is 10 volt, and this is 4 ohm, and this is 6 ohm. Now here we need to calculate the VTH. Now across these two terminals we need to find out the VTH. Now here give the current directions. At 4 ohm current is I1, at 6 ohm current is I2. Now in this case first apply KVL in a single loop. So here now we are having the one single loop here. This is one complete one single loop. So in this single loop apply KVL. So here I am starting from this point. So apply KVL. So when we are applying KVL, we will get equation like this: plus 20 minus. So here plus minus and plus minus. So minus 4I1 minus 6I2 minus 10 equal to 0. Here is the KVL equation, right? So now by simplifying this, so 20 minus 10 will get 10, that is equal to 10 I1. Here we are having only single loop, means it is a series circuit. So in series circuit, and 4 ohm and 6 ohm are in series. So in series current is constant, means since I1 is equal to I2. So these two currents are same. So I1 or I2. So here I1 is equal to or I2 is equal to, will get 1 ampere. Here is the current value. Now we need to find out VTH. So our second step is we need to find out the Thevenin's voltage VTH. Now in that case, so here I am taking the source here, that is VTH plus minus. Now in this case apply KVL in this loop or apply KVL in this loop. So we will get VTH value. So apply KVL in first loop or apply KVL in this second loop, we will get the VTH value. So here now I am applying the KVL in first loop. So in that case here also I am starting from this point. So the equation is plus 20 minus 4I1 minus VTH, that is equal to 0. So where VTH is equal to 20 minus 4I1. So I1 is nothing but 1 ampere. So that is equal to 16 ohms. Or apply KVL in second loop. So apply KVL in the second loop. Also will get the same answer. So here I am applying KVL in the second loop. So here the equation is plus 10 plus 6I2 minus VTH equal to 0. So where VTH is equal to 10 plus 6 into I2 also 1, that is equal to 16 volts. So this is the Thevenin's voltage VTH, or we can use this loop also, that is VTH is equal to 16 volts, right? This is our second step. So here the second step is we have to find out the Thevenin's resistance, that is VTH, Thevenin's voltage, that is VTH equal to 16 volts. So here is the VTH value. Now the third step is we need to find out the Thevenin's resistance. So that is step number 3. Step number 3 is we need to find out, or we need to finding of RTH, Thevenin's resistance RTH. Now in that case, so if the circuit having the voltage source, means we need to short circuit the voltage source. If the circuit having the current source, we need to open circuit the current source. But in our circuit we are having the two source voltages, so we need to short circuit the two voltages. Okay, so here is the circuit. So here we need to short circuit the voltages. So this is first voltage source, this is short circuited, and this is second source voltage, this is also short circuited, and here we need to remove the load. So load is here, here we need to remove the load. Now across these two terminals we need to calculate the RTH, that is Thevenin's resistance. So here is the values are 4, 6. So 4 ohm and this is 6 ohm. So now in this case, now we need to find out the RTH value. Now here, suppose here we are having the source. So the current towards this point, so from this point current is dividing. If the current is dividing means the two elements are connected in parallel, or same current is flowing means the two elements are connected in series. Now in the given circuit, 4 ohm resistor and 6 ohm resistors are connected in parallel. So if any two resistors are connected in parallel, the equation is R1 R2 divided by R1 plus R2. So here RTH is equal to R1 R2 divided by R1 plus R2. So means 4 into 6 by 4 plus 6. So that is equal to 24 divided by 10, that is equal to 2.4 ohm is the RTH value. Here is the Thevenin's resistance RTH. Okay. So here previously we are calculated Thevenin's voltage, and next one is Thevenin's resistance. Now finally the last one is, so according to statement of Thevenin's theorem, according to statement of Thevenin's theorem, the total voltage is replaced by Thevenin's voltage. So here Thevenin's voltage, that is VTH, and the total resistance is replaced by RTH in series with load. So load is RL. Now so we are calculated VTH value. So VTH value is 16 volts. So this is 16 volts, and RTH is 2.4 ohm, and RL value is 10 ohm. Now across this load we need to calculate the IL value. Now we need to calculate the current through 10 ohm load resistor. So here is the equation. So current through load equal to, so here also we have to use the Ohm's law, I equal to V divided by R. So that is in the place of I, IL is there. So IL is equal to, in the place of V, VTH is there, and divided by R. In the place of R, RTH is there and RL is there. So these two are connected in series, means RTH plus RL is the equation. So that is equal to, so VTH value is 16 divided by RTH value is 2.4 plus 10. So here by calculating this, here by calculating 16 divided by 2.4 plus 10, so we will get 1.29 amperes is the load current IL. This is the current through 10 ohm load resistor. Okay, this is by using the Thevenin's theorem. Now we have to verify if it is right or wrong. So now we have to verify. So by using the Kirchhoff laws, or by using the nodal analysis, or by using the mesh analysis, we have to verify the Thevenin's theorem. So here I need to verify the Thevenin's theorem. By using, I am taking the nodal analysis here. So here for the main circuit is, so verification. So the verification of Thevenin's theorem. So this is plus minus, and this is 4 ohm, this is 6 ohm, 10 ohm, this is 20 volt, and this is 10 volt. Okay, so here by using the nodal analysis, we need to find out the current through this load, that is 10 ohm load resistor. So here in the given circuit, so first we have to find out the total number of nodes in a given circuit. So here we are having the one single node here. So this is, so node is nothing but the three elements are connected at one single point, that we can call it as a node. So here we are having the only single node, that is V. I am taking as a node voltage is V. Now apply nodal analysis here. So we will get the equation V minus 20 divided by 4 plus V minus 0 divided by 10 plus V minus 10 divided by 6, that is equal to 0. Why I am taking equal to 0? Because here there is no current source, that should be equal to 0. Now by solving this equation, we will get equation like this: V into 1 by 4 plus 1 by 10 plus 1 by 6, that is equal to 20 by 4 plus 10 divided by 6. Now here by solving this entire equation, so V into 1 by 4 plus, so by solving the entire equation, V into 1 by 4 plus 1 by 10 plus 1 by 6, that is equal to 20 by 4 plus 10 by 6. So by solving this entire equation, we will get node voltage V equal to 12.906 volts. Okay, V equal to 12.906 volts is the node voltage here. But here in this case, we need to calculate current through this 10 ohm resistor. So here I am taking current as IL, load current IL, right? So here IL equal to V minus 0 divided by 10, that is equal to, so 12.906 divided by 10, that is equal to, we will get 1.29 amperes. Here is the load current IL value. So here finally we can write, from the nodal analysis we have to verify the Thevenin's theorem. Hence the Thevenin's theorem is verified. This is the procedure to calculate the current through the load resistor. Okay, so here in today's lecture, so we have discussed about the statement of Thevenin's theorem and what is the procedure involved in the Thevenin's theorem, and one example. So I am taking the two loops circuit, and by using the two loops circuit we are calculating the current, and here we are verified, and here is the verification of the Thevenin's theorem. Okay, so thank you one and all.